into solving systems of equation with our new unit today. So unit 6 is all aligned with systems. And you need to know what a system means. A system is two or more lines that may or may not have an intersecting point. So when we are solving systems, it means that I want you to analyze the lines and tell me if the line intersects or doesn't intersect. So here would be a system that does not intersect because these lines are parallel. Here would be a system that does intersect. They have one intersecting point. You either intersect at one point, never intersect, or you can be a multiple and you can have an infinite amount of intersecting points. They can be the same line. What you're going to do with systems knowledge. Now systems just means more than one line. That's what a system means. They might intersect, they might not intersect. What you have to apply with systems is identifying a solution. Now if a system is a representation of one or more lines, a solution tells you about those lines. It tells you where the lines intersect. So a solution is a point on a graph that satisfies both lines. Meaning if it satisfies both lines, it's a part of both lines, so it is an intersecting point. That's what you're going to do all this chapter. This chapter you are looking at lines, you're arranging them sometimes, you're graphing them, you're substituting, you're combining them, you're trying to figure out where they intersect. That is our purpose of this whole chapter. So, it's where they intersect. System, more than one line. Solution, find the solution of a system. Where do they intersect? Notice this one. Where do they intersect?
Nowhere.
Never. So you would say something like this. No solution. You may or may not have one like that on your homework today. We get more into those special ones in an upcoming lesson. Okay, so here's the steps. Today we're not going to have to apply this too much. We get a nice beginning introduction lesson to it. But you want to make sure they're both in slope-intercept form. So let me just write y equals mx plus b. Because you want to be able to graph. Okay, write it down. Make sure they're both in y equals mx plus b form. Slope-intercept. And then guess what you do? You graph them. That's what you do. You graph them. You make sure that y is alone. You graph it. And then if we're identifying a solution, you figure out where do they intersect. Everybody's answer should look like this today. You should have an x and a y. And it should be within parentheses. If you just write 1, 2, I will not give you credit. That's just a sequence. 1, 2. And I'll be like, oh, I should write 3, 4, 5, 6, 7, 8. You have to specify it's a point on a coordinate plane. You have to include parentheses. Do you hear that? Do you have to include parentheses? Yes or no?
Yes.
Sure do have to include parentheses. And you need to remember that x is first. Let's apply it. So flip that page over. Okay, I am going to be given a system, more than one line. System, more than one line. I am going to be given a system and I want to identify the solution, where they intersect. So here's my system. This is considered a system. Okay, that's my system. It's more than one line. System. I'm going to graph both of them. So I'm going to go ahead and plus a negative. Be careful for your graphing. Sometimes if your line starts looking crazy today, chances are you're using the slope wrong. Maybe you forgot it's a negative slope or something like that. Okay, so the first one has a y-intercept of -3, so I make a dot at -3. My slope is down 3 over 1, not up 3, down 3 over 1. 1, 2, 3 over 1, down 3, 1, 2, 3 over 1. I'm going the other way too. Up 3, 1, 2, 3 over 1. Make the dot. Up 3 and over 1. Okay, there is my first line of the system. Now I'm going to make my second line of the system. So I have a y-intercept of 2. So I'm going to make my y-intercept of 2. And then my slope is up 2 over 1. Up 2 over 1. Up 2 over 1. Notice I'm getting nowhere, look at me. Notice I'm getting nowhere near the line. So I definitely need to go the other way because I'm trying to find where they cross. Down to this way 1, found it. Down to this way 1. Do these two lines intersect?
Yes.
Then the solution of this is their intersecting point. So it looks like x is at -1, y is 0. The solution of this system is -1, 0. It's new terminology. Solution means the point of intersection. System, more than one line. Your homework today is aligned with this, where I have y isolated for you all today. We'll get more to the level 3.54-ish type questions on Monday. But you're going to graph two lines, identify the solution where they intersect. The next line, I have a y-intercept, or no, the next system. This is a system, right? 2 lines. So the first line, I have a y-intercept of 4, 1, 2, 3, 4. A slope of 2, up 2 over 1. 1, 2, over 1. 1, 2, over 1, down 2, other one. Wait, I went down 1 over. Down 2 over. There we go. Okay? And then my other one, can I graph this bottom one?
Not yet.
Not yet. I can't graph this yet because y has to be by itself. So I need to get x to the other side before I graph it. Don't forget that. Some of you forgot that on the Unit 5 test. Y has to be alone. Y equals x plus 2. And now I can graph it. So I have a y-intercept of 2 and a slope of 1. Up 1, over. Up 1, over. Up 1, over. I can see I'm getting nowhere near the line that I'm trying to intersect. So I'm going to go the other direction. Down 1, over. Down 1, over. Found it. Okay, where do these two lines intersect? Mine is scaled weird. What does yours say? Is yours scaled nicer? Where do these, huh? -2, 0. That's what I would analyze too. But my grid is scaled weird because I zoomed it out, so it kind of unaligned it. So let me that's all I want to do with you today. So nice short Friday lesson. The goal, you have to graph a system more than one line. Find the solution. Solution means where do they intersect?